The dark energy can be explained with the two major problems. The first one is a naturalness, and the second one is a coincidence problem. So the first one, naturalness or fine-tuning problem, is that the dark energy density is extremely smaller than compared with the compatibility result. So from the observational result, the dark energy densities are related with the critical density coming from the Bohr-Brodmann equation, and that this is the smaller than the Planck mass scale in the mass dimension of the ball. But in the quantum field theory, one candidate of dark energy, which is the vacuum energy, has the scale of the Planck mass from the cutoff. So that there are 10 to the minus 120 difference between the quantum field theory results and the observation. This is called the naturalness problem. And the second problem is the coincidence problem, because that during the cosmic history, other components that evolves like 8 to the minus 4, 8 to the minus 3, but for the cosmological constant, the dark energy has the static energy density. So in the early universe, the matter energy density is extremely greater than the dark energy ones, but in the far future, this will be swapped. But in our universe, especially this current moment, the dark energy density and the matter's energy density is almost comparable. And this is called the coincidence problem. So to resolve these two issues, or partials of them, one can introduce the dynamical dark energy with the varying equation of the state. So in this case, now the energy density of the dark energy is the varies. And the well-known dynamical dark energy model is the quintessence with the inverse power of potential. And such inverse power of potential satisfy the tracking solution. So consider that there are a scalar field Q, which is called the quintessence, and it has the following inverse potential. And for the large Q, the potential has a very flat slope, so it can satisfy the accelerating conditions. The scalar fields in the expanding universe follows this equation of the motion, and if we try some field evolutions of this time with the power law, then the quintessence satisfies the following solution. And also one can calculate the energy density of the quintessence with the kinetics and the potential energy. And let us assume that the universe is dominated by the single component like the radiations or matter, and that this has the static equation of the state WB. During these eras, the low B and the scale factors are determined, so we can substitute this and obtain how the energy density of the quintessence evolves as a function of the scale factors. By solving that, we can obtain the equation of the state of the quintessence. This is given by in terms of the power law index of the quintessence potential and the equation of the state of the baryon. When the alpha is larger than the 0, because power law index is positive, then the quintessence equation of state is smaller than the baryon. So the quintessence density decreases more slowly than the backgrounds. So as a result, the lattice evolves with the following relation. So this lattice eventually grow, So even if the original initial dark energy density is smaller, it can eventually reach the dominance in the light universe. And especially the wide range of differential conditions can converge to the some scaling solution. This is called the tracking solutions or tracked behavior. Such attractors or tracking behaviors of the inverse power potential can be understood more qualitatively from its shape. Because the potential is very steep at the very small q, and becomes the flat when the q size increases. So it loses energy and its energy density decreases rapidly. And if the build starts with the two small energy, which means a very large q, the potential is very flat, so build moves very slowly, so it remains nearly frozen. So the eventually it follows the attractors tracking behavior. Also, there is some self-regulating mechanism to drive the wide range of conditions that eventually converges to a common tracking solution. Mathematically or quantitatively, this can be shown by the following property. We can define the tracking parameters capital gamma as combinations of the second and first derivatives of the potential. And this is just given by the functions of the alpha. When the capital gamma is around 1, this is conditions for the tracking. Now one can define the dimensional slope parameters as the second first derivatives of the potential. Then the evolutions of the slope parameters satisfy the following equation. And when the capital gamma is around 1, this becomes a negative, the right hand side. And when the q increases, the lambda decreases, which means that the slopes are decreased. So the tracking behaviors requires the effective the flatness of the potentials as builds are low. So the point is that such inverse potentials of the scalar fields can realize the dynamical dark energies and they can resolve the partial problems of dark energies, especially the coincidence problem. But how can we realize that there's such a quintessence potential? In the non-supersymmetric theories, the scalar fields are protected against the loop corrections. Such a radiative correction can generate the additional terms to the potential, and this makes effective terms. And this makes the several polynomial terms, especially the quadratic terms, and this can induce the effective mass coming from the loop. And this interrupts the behaviors of the quintessence eventually. And this induced mass has a scale of the Hubble parameters. And this destroys the tracking solutions. And also that there are many higher dimensional operators. If these terms are not forbidden by the symmetry. So in the non-supersymmetric framework, there are no mechanism to prevent such radiative corrections, which makes the spooling of the planets of the potential. So one consider that the supersymmetric realizations of the inverse polar quintessence based on the strongly coupled supersymmetric gauge theory. First of all, this gives the inverse potential form naturally. Second, the supersymmetry ensure that the non-normalization theorems that there might be no radiative loop correction. In the SUSY gauge theory, which is called the supersymmetric QCD, with the large NC, then the NF, whereas ANSI means that the number of the color, and NF means that the number of the fermion generation. In such a theory, non-perturbative dynamics generate the uniquely determined ADR superpotential. We will cover this idea of superpotential in the supersymmetric video later, but it has a following form with the inverse potentials of the scalar field. Here is capital lambda is some specific cutoff, and the W is in the superpotential. And we can obtain the scalar potential by the term by differentiate the superpotential through the scalar fields, and the summations of each scale gives us scalar potential. And after reducing the multiple system, then we can obtain the potential has the inverse Pavlov form, and this explains how the inverse potential form naturalists can generate this in the supersymmetric model. And also the supersymmetry ensures that there is no radiative correction, because the supersymmetry satisfies the non-normalizable theorem in the presence of the holomorphy. Holomorphism means that there is no dependence of the conjugate superfield. So superpotential does not receive the perturbative contempt corrections, and also supersymmetry cancels the quadratic divergence like as the gauge hierarchy problems of the Higgs masses, because there are boson and fermion pairs in the SUSY theory. However, there are still the problem in the supersymmetric theory. The tracking solution requires that the present values of scalar fields should have the order of the Planck scale, and such a large field value can induce the gravitational effect. And the global supersymmetry must be replaced by the supergravity, which is the local versions of the SUSY. And in the supergravity, the scalar potential requires the additional term beyond the superpotential. But in the exponential, there is a scalar potential, so that this ruins the holomorphy, because the scalar potentials depends on the conjugates of the superfield, and there are also the higher dimensional operators of the superpotentials with the Planck mass suppressions. And such a scalar potentials and the additional gravity effect can modify the behaviors of the inverse potentials in the large field value. So today we talk about how the dark energy can be explained by the inverse potentials, and they can be realized by the supersymmetric theory. In the dark energy, there are two fundamental difficulties. The first one is the naturalness problems, and the other one is the coincidence problem. And dynamical dark energy with the quintessence replace the cosmological constants to the dynamical field values through with the inverse potentials. But such inverse potential can realize the tracking through or the attracts the behaviors through which ensures that the wide range of the initial conditions eventually converges towards the common solutions. And this can partially alleviate the coincidence problem. But in the non-supersymmetric theory, the scalar fields are not protected by the radiative loop correction, and this generates the mass stems and a higher dimensional operators which destroys the blood inverse potentials and spoil the tracking behavior. So the supersymmetric theory proposes to give the naturally the inverse potentials from the ideal superpotential, and also the supersymmetric theories can ensure the non-renormalizable theorems and the cancellation of the quadratic divergence without some specific loop correction. But nevertheless, there are still problems in the supersymmetric theory for the dark energy model, because the present values of the quintessence scalar fields has the order of the Planck scale, and the gravitational effects are important. So if we consider the local supergravity theory, then there will be the additional correction from the scalar potentials and also the higher dimensional superpotential. And also this can be altered like time evolutions of the quintessence scalar fields. So today I talk about this dark energy models in the dynamical versions, and how can the supersymmetry realize such inverse potential.